Okay, so compound inequalities 1.9. So we are getting closer to our test. Our test is going to be next week, I believe Wednesday or Thursday, but I would have to look back at the calendar. So if you are at this point unsure, what inequalities mean or need any help with the notes or exit ticket, let me know. Reach out. We can meet before school, after school, or potentially during my lunch or conference period, 4th or 8th. But again, just got to reach out, ask for help, be accountable. So, all right, compound inequalities. What we're going to learn about these is that a compound inequality means that you're going to take two inequalities and you're going to put them together. So maybe it's like x is greater than 3, but x is also less than 5. So the only number that would work for, if it's bigger than 3 but less than 5, we know has to be 4, right? Well, that's essentially a compound inequality. There are two different types of compound inequalities, as you can see here. Okay, two different types. Type number 1 is an OR, okay? So it's an either-or statement. So for example, x is greater than 6 or it's less than 2, okay? So an OR statement, usually there's no overlap. Like in this other one, it was like x is greater than 3 and it's less than 5 because there's this overlap. Where if you think about a number line, I'd have 3 and 5, and it had to be bigger than 3, right? But then it had to be less than 5, and so the only number in there would have been 4. So that's an overlap. That's the second type. That's called an AND statement. All right, so if there's overlap, that's an AND statement. If it's not overlap, so like in this example, in the first one, you have x is greater than 6 or less than 2. So if this is my number line, it would have to be greater than 6 or less than 2. So you can see there's no overlap here. It goes left and it goes right, but there's nothing in this spot. It's empty. So that means either the number is going to be bigger than 6 or it's going to be less than 2, but it won't be anything in the middle here. So there's two different types, an OR or AND. If it's an AND statement, it has to satisfy both properties, which is where the overlap comes from. So it has to be true for this, and it has to be a true statement for this. It has to work for both of them. For an OR statement, it can be either one or the other. It doesn't have to be both. So like the number in an OR statement that would satisfy this first example would be 1 because it's less than 2. It doesn't matter that it's not bigger than 6 as long as it's less than 2. Okay. So let's look through. These compound inequalities can be written in two different ways. So the first way that you write an AND statement is just like you see above. So you write them both separately and then put the word AND in between. So we could say like x is greater than 2 and x is less than or equal to 10. Okay, and we can find a number that overlaps in those. The second statement, and also notice which direction the inequalities go. When you have an AND statement, if you're writing them separately, they point towards each other, right? Like this one points this way, this one points that way. So that tells you there would be an overlap. The second way that you could write them, so like this first example, is you could take the two numbers, so the two numbers are 5 and 10, and we know x is going to be between them, so we're going to go ahead and put a b between, and we know that it's going to be less than 10, it says, and it's going to be bigger than 5. So the second way that you could write them is just one full compound inequality, okay, compound inequality, but the sign's going the same direction. And most of the time, it'll be this direction as long as you have the smaller number on the left. Actually, I should say all the time. I can't think of a situation where it wouldn't be. All right, so let's check for solution examples. So we're going to look at these inequalities and figure out, is it a solution? So the first one, is 5 a solution to the inequality x is less than 12 or x is greater than 5? So remember, 5 is not greater than 5, but 5 is less than 12, and since it's an OR statement, yes, because it satisfies this one, okay? And an OR statement, only one. All right, is 13 a solution to the inequality x is less than 12 or x is greater than 15? So 12, 15, okay, 15, x is greater than, it would go this way, x is less than, it would go this way. 13 is somewhere here in the middle, right? So that's a no. Okay. Okay, is negative 2.5 a solution to the inequality x is greater than negative 2 and x is less than 5? So if we go to 5, negative 2 goes this way and goes this way, right? So it goes both directions. We have this overlap. So negative 2.5, where is that? Well, that is over here, right? That's in between negative 2 and negative 3. So that's a no. Okay, write this inequality in another way. Okay, so since it was an and statement and they had it as two separate, now we're going to put it together. So put the numbers on the outsides, put the x on the inside, and then I would start here with this one. X is less than 5, okay, and then you know it has to go the same direction. Okay, and you can look at this one too. You can see the mouth opens up to the bigger number. Mouth opens up to the bigger number. So since it opens up to x, it should also open up to x for this one. Okay. All right, is 4 a solution to the inequality x is greater than negative 2 and x is less than 5? So 5, negative 2, overlap in between. 4 is right here. Yes. Yes, it is. Okay. All right. So solve compound inequalities and then graph them. So here's what this one looks like. You're going to basically solve the inequality, but it's either going to be two different inequalities like these or statements, so you have to solve both of them, or it's going to be an and statement like this where it looks like all just one. Okay. Sorry, took a bite of my oatmeal there. So let's go ahead and solve this. What you want to do is work from the inside out. So we have this letter A in the inside. Okay, that's what we're going to solve for. And you can see we have this negative of 5 attached to it. So as you recall, if we kind of ignore this left side for a minute, this looks like an equation, right? So we would solve for A by adding 5 to both sides. Okay, well when you have a compound inequality, instead of drawing one line and organizing your thoughts, it's going to be two lines, and you're going to do it to both the inside and both of the outsides. Okay, so now left over on the inside, I have an A. On the outside right, I have a positive 2, and on the outside left, I have a negative 3, and I keep my symbol. So we just solved that. It says A is less than 2, but it's also bigger than negative 3. So negative 3, it's an open circle because it's a greater than or less than. There's no line underneath, right? That's what we learned yesterday. Okay, so it's an open circle at negative 3 and an open circle at 2. And since it's an and statement, the line is in between, and you can draw a line like this. Oops. Line like this. You could draw a line like this. I'm fine with either way, okay, because those are all the solutions. So any one of these are the solutions. Okay, so here's another and statement, but instead of it being written all together, now it's written separately. So this one's a little bit easier because we're going to just treat it like two different equations that we're going to solve. We're going to draw a line down through the inequality symbol. And we're going to solve this one first on the left, and then we'll solve the other one. So we want to get k by itself. We're going to add 3 to both sides. Negative 6k is greater than negative 36. Okay, and then I'm going to divide by negative 6 on both sides, and I have k is less than 6. All right. Now, pay very close attention. Look at the signs. Okay, remember we talked about this yesterday. If you multiply or divide by a negative, you got to flip that sign. So I flipped the sign. This was a negative, so I flipped the sign. Okay, let's go ahead and solve the other one now. Subtract 2 from both sides. So I have 12k is 36. Divide by 12, divide by 12. So k is greater than 3. Okay. And I didn't have to flip the sign because I didn't multiply or divide by negative. So let's go to 3. Okay, let's go to 6. And the inequality says it's bigger than 3, less than 6. Bigger than 3, less than 6. So it's got to be this overlap. Okay. Keep going here. So now this is an or statement. Again, I'm going to treat it like two different inequalities because they're two different. There's an or in between. So we're going to add 3 to to solve for v, which gives us -5. So that one's done. And then on this side, we're going to divide by 6. So v is greater than or equal to 6. Okay, so there's our solutions there. So less than or equal to -5. Less than or equal to -5. And greater than or equal to 6. And again, to check to see your arrows are going the same or the correct way. If it's an or statement, they go opposite. If it's an and statement, they go together. Okay? Or apart and together. So this is an or statement. We already know that the arrows should go separately. They go different directions. We're going to go ahead and solve. So we're going to add 4, x is less than or equal to -4, divide by -3, divide by -3, so that makes me switch the direction of the arrow, okay, and so there's your answer for that. So less than -4, but greater than or equal to -2, it's an or statement, so less than -4, but greater than or equal to -2. Okay, all right. So just a couple examples here left before we get into the practice and exit ticket. Write the correct compound inequality for the following graphs. Okay, so as we look, notice it goes opposite, right? So this is an or statement. Okay, you have 0 and 5. So we have 5, 0. And this one goes left, and it's an open circle, so we know that one is x is less than 0. And then this one goes right from 5, so that's greater than. And since it's a closed circle, it's greater than or equal to. So there you go. Okay, next one. Okay, it fills in the blank, so that's an and statement. There's two ways to write this. You have an open circle here and a closed circle here, and it's at -5 and 5. So there's two ways to write it. You could say x is greater than -5 and x is less than or equal to 5. Or you could also write it as -5, 5, x less than or equal to, and there you go. Okay, so either one of those is the correct answer for this one. Okay, last problem here. Ski shops carry skis that are between 150 and 220 centimeters long. They recommend that the skis be 1.25 times longer than your height. Okay, so they have to be a little bit longer than your height. Calculate the tallest height that a person can be and still rent the skis. Okay, so 150 and 220 are total, so those are going to go on the outside. And all we have to do, by the way, is first write the inequality and then solve it. 220. Okay, and then in the inside, we know it's got to be less than or equal to that, and greater than or equal to 150. It's got to be somewhere in between. Now, in here, we have x, but it says 1.25 times longer than that. So this is 1.25 times that. Okay, so now we're going to divide, solve for x, and again, since it's two inequalities, we're going to do this. Okay, and those numbers, let's see, 150 divided by 1.25 is 120, and 220 divided by 1.25 is 176. So, there's your answer. The tallest person is 176 centimeters long. They can rent the skis. All right, so there's a practice here. I'm going to go ahead and post the key to this on Canvas as well. And then your homework tonight is going to be completing that exit ticket and submitting that. So have a great day. Let me know if you have any questions, and I will see you.